Every DC gadget in your home starts its life connected to alternating current. By chopping an AC wave in half, we take the first real step toward converting household power into usable DC. Today, we're constructing a basic half-wave rectifier on a breadboard. We'll be using a 120 volts to 12 volts transformer, and I'll highlight the exact safety precautions you need to take before handling high-voltage primary lines. Alternating current does exactly what the name says. It alternates. The voltage swings positive, then negative, 60 times a second here in North America. A diode is a one-way valve for electricity. Current flows through it in one direction from anode to cathode, but it blocks flow in the other direction. The cathode is the end with the stripe on the physical part. Here are all the components you need to set up the circuit. A 1N4007 rectifier diode, a 1 kilo-ohm resistor, a 1000 microfarad electrolytic capacitor, a red LED, a 120 volt to 12 volt step-down transformer, a breadboard to connect everything together. Let's set up the circuit step by step. Bend the ends of a 1N4007 rectifier diode. The cathode is on the left side of the breadboard. Insert the diode in the middle of the breadboard and the positive rail. Insert a 1000 microfarad capacitor into the same row as the diode and the negative rail. The cathode is in the negative rail. Bend the ends of a 1 kilo-ohm resistor. The 1 kilo-ohm resistor is in the same row as the capacitor and a few rows below it. Insert a red LED into the same row as the resistor and the negative rail. The cathode is in the negative rail. It's time to connect the power supply. Insert the yellow wire to the positive rail. Insert the blue wire to the negative rail. Insert the other unused blue wire into a wire cap. Now that the circuit is complete, let's power it up. The LED shines bright red within its safe operating voltage. To make sure it isn't taking too much voltage, which could fry it over time, let's quickly check it with a multimeter. To measure DC voltage across an LED, turn the multimeter's dial to the DC voltage setting. Touch the red probe to the positive terminal of the LED, while placing the black probe on the negative terminal. The multimeter reading is approximately 2 volts, which aligns with the typical forward voltage expected for a red LED. By utilizing the negative halves of the waveform as well, a full-wave rectifier effectively doubles the output pulse rate to 120 pulses per second. If you would like to explore this topic further, simply click on the next video to continue. If you want to learn more about building circuits and electronics from the ground up, check out my Getting Started with Electronics ebook. It walks you through the fundamentals, components, tools, and how to read and build real circuits, so you can start designing your own projects with confidence. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.